Hey everybody, Mr. Bohorik here, and let's talk about simplifying radicals. First thing we need to know is about this radical multiplication property. So, for example, if I have the square root of some number x, and I'm multiplying it by the square root of some number y, since these are both square roots, I can combine them into saying that's the same as the square root of x times y, all underneath the radical. So with numbers, let's look at this with numbers. So this is algebraically, and so numerically, let's say an example, let's say a square root of 4 times the square root of 9. That should be the same thing as the square root of 4 times 9, okay, or the square root of 36. And you can test that out. The square root of 4 is 2, and the square root of 9 is 3. So I'm looking for 2 times 3, which is 6. Since it's equal to the square root of 4 times 9, or the square root of 36, the square root of 36 is also 6. So you can see that this property totally works. Now, that property is going to help us simplify radicals. So what do I mean by that? Well, we don't always get, nice, pretty, like square root of 36 or anything like that. It's taking the square root of a perfect square. Sometimes we have examples where we'll have to do the square root of, let's say, 28. That's not one of our perfect squares, and we want to break this up into different factors to make this look a little bit easier. Kind of small, like we're shortening up the numbers a little bit, I guess is the way to think about it. So I don't want to do the square root of 28. I want to break up 28 into different factors. And what I'm doing is I want to pick a factor that's a perfect square. Preferably, I want to pick the largest perfect square that goes into 28. But you can pick whichever perfect square comes to mind first. Okay? I usually want to pick the largest one because it'll be less work. And I'll show you in an example in just a little bit. So a perfect square that goes into 28, well, the first one I'm thinking of is 4. So the square root of 4 times 7. Notice how I broke that up. I just broke 28 up into 4 times 7, which is 28. Well, knowing what we know about this property over here, we can break that apart into the square root of 4 times the square root of 7. Well, take a look. Don't we know what the square root of 4 is? Well, yeah, it's 2. But we don't know what the square root of 7 is, and I can't think of any perfect squares that actually go into 7. So we just leave it as the square root of 7. So the simplified version of the square root of 28 is 2 square root of 7. And you can punch that in on a calculator. Type in the square root of 28, see what you get, and then type in 2 times the square root of 7. You'll get the same answer. So this is just a simplified form of the square root of 28. Let's take a look at another example. Say I have the square root of 72. Now, the first thing, perfect square that comes to my mind is 36. You were thinking of something different? That's okay. We'll do that in just a second. So when I break that apart, I'm doing the square root of 36 times 2. Because 36 times 2 is 72. So I can break that apart into the square root of 36 times the square root of 2, based on that property seen above. And I know that the square root of 36 is 6. And the square root of 2, I can't think of any perfect squares that go in that besides 1, of course, but that doesn't really help us. So I just leave that as the square root of 2. And my answer is 6 square root of 2. That's the simplified version of the square root of 72. Now, you might have been thinking of something else. So when I said the square root of 72, you might have broken that up into a different pair of numbers or a different set of factors. Let's take a look at that. You might have said, well, isn't that 9 times 8? Bet it is. So we can say that's the square root of 9 times 8. And that's okay. We can do that because 9 is a perfect square. Remember, you only want to break these numbers up into perfect squares. So a perfect square times another number is what we're looking for. So we can say that's the square root of 9 times the square root of 8. Well, the square root of 9 is 3, but wait a second. Can't we break up the square root of 8? Yeah, there's a perfect square that goes into that. It's 4. Square root of 4 times the square root of 2. So now we have 3 times the square root of 4 is 2 times the square root of 2. We just leave that alone because we already said there's no perfect squares besides 1 that go into the square root of 2. So 3 times 2 is 6 times the square root of 2. So you notice that we get the same answer. Okay, we broke it apart differently, and this one took a little bit more steps. And this is why I said earlier that it's helpful that you want to pick the largest perfect square that goes into that number. And the reason why we pick the largest perfect square is because, well, there's less steps. Okay? Less chances to mess up is the way I think about it. If you don't pick the largest perfect square, it will work. You're just going to have a little bit more work to do. Okay? So I recommend just picking the number that you find that goes into that easiest. So if you look at 72 and you immediately know that 9 goes into 72 right off the bat, start with that. Okay? You might as well start with that because you know that. So don't try to be like 36 or anything like that. Yes, 36 works, but it's better to go with the one that you're sure about rather than the one that you're kind of like, maybe that works. So, and if you have the time, try it anyway. So, all right, well, I'm Mr. Bork, and you can find a bunch of examples of this stuff on my website, and we'll be doing a bunch in class. So, but that's pretty much the gist of simplifying radicals.